Hi and welcome to our next level 2 probability video. In this video we're going to continue talking about the standard normal distribution. The standard normal distribution is a normal distribution curve that's been converted to get a mean of 0 and a standard deviation of 1. It's useful when we compare different data sets and also helps us to solve much more complicated problems. We're going to introduce the following formula. Basically what we're going to do is, instead of using the graphics calculator now, we're going to show you how to solve these probability problems manually by hand without the graphics calculator. So here's the formula. Z is equal to x minus mu. You've seen mu before, that is the mean, all divided by sigma. And you've seen sigma before, that is the standard deviation. So the only thing you probably aren't familiar with is, what is Z? Z is the number of the standard deviations that you are away from the mean. And I'll try and explain it with our example. All right, let's get into example. The height of 1,000 Year 12 students is normally distributed with a mean of 168 and a standard deviation of 8 centimeters. You can see the curve drawn above. The mean is in the middle at 168 centimeters. Now the question we're going to solve, what is the probability a student is greater than 180? So we've marked 180 on the diagram above, and we've coloured in all the students greater than 180, which doesn't look like a lot. So when I get my answer, I know it's not going to be a great, the highest percentage. All right, here are the statistics that we need. Mean of 168, standard deviation of 8, and x is 180. So if we were to use our graphics calculator, we'd get a probability of being greater than 180 of 0.06681. And I rounded that to 4 significant figures. But I'm going to solve it manually without my calculator. So this is how I do it. We're going to use this formula. Z is equal to x minus mu over sigma. So we get 180 minus 168 over 8. Now 180 is the x value that I want to be less than or greater than. 168 is my mean, my mu, and 8 is my standard deviation, my sigma. Now if you solve that on the calculator, you get Z is equal to 1.5. And I'm going to redraw my normal distribution curve here. Instead of 168 in the middle, I've got 0. Instead of 180, greater than 180, I want to be greater than Z is equal to 1.5. Now let's quickly try and explain what Z greater than 1.5 means. We know the distance away from the mean up to 180 is this distance. Now, one standard deviation represents 8 centimeters. Half a standard deviation would be half of 8, which would be 4 centimeters. So 1.5 standard deviations is 12 centimeters. And that's the distance between 168 and 180. 12 centimeters, which represents 1.5 standard deviations. So when you think about Z, think of how many standard deviations away from the mean. All right, let's go back to these tables and remind you how to use them again. What if I said, oh, that was the formula, by the way, that we used to get these probabilities. Let's not worry about that. So what if Z was 1.5? We'd get 0.4332. What if Z was 1.57? We'd get 0.4418. What about Z was 0.32? We'd get 1.255. Now let's go back to the problem we're dealing with. Z is 1.5, which we work out as 0.4332. Now that actually gives us the area between 0 and 1.5, the light blue area. That's not what we want. We want the dark blue area greater than 1.5. So we're going to be cunning, and we're going to work out what 0.5 is, which is half the area, because it's half between the mean and above. And we're going to subtract the 0.4332 to get 0.06680. And when we go back and compare that to the graphics calculator, the answers are almost perfectly the same. Great. Thanks for watching.